Okay, welcome back. So today we're starting Module 3. The first thing to do is go to the Canvas site and get the Google Colab notebook. That's where we're going to start. I'm not entirely sure which of these, hopefully they both work, but which one is more convenient, I don't know. So the first one is a file, the notebook is uploaded to Canvas, so that should download it to your computer. And then you'll have to, there's a couple ways. You'll have to get that into Google Drive or into Google Colab. From there, the other one is a link to the notebook that will take you directly to my Google version of it, which I think you may be able to do from Google Drive itself. Right. So this is one of the things that I can't exactly work through from your end, and because since I own it, of course it opens for me. And then the second one, the beginning bioinformatics, is a Word document, just like the tutorial for part 1. That's the second part that I hope we get to today. Overall goals for today are to introduce you to Colab. That's what the Python notebook is for. And then get you going, starting to learn Python. I haven't had a chance to look at the quizzes yet, which is why I'm not going to go over them right away. I'll spend some time Thursday. If you have questions after class, feel free to come ask. So I'm just giving people a second to get to Google Colab. So you should know how to get here from the account setup steps. If you navigate directly to Google Colab, like you just Google it and then click the link to go there, you'll get an option to open files, which later we're going to start a new notebook. Excuse me, but for now, this is where you would upload, right? You can drag and drop your file that you've downloaded to your computer right into here. I don't know how the share link, I just haven't had enough opportunities to explore how it works. Somebody shares that notebook with you and how you open that on your end. But the notebook we should be looking at is the Intro to Colab. How many people already have it open? Oh, good. This is one of those things where when you're changing the whole platform, it's like cross your fingers and hope. And honestly, the fact that more than half of you raised your hands just now means that it's already way better than the old way. Because we would have spent all day today installing Anaconda and getting their Spider IDE working in all of your different computing environments. So one major headache avoided.
Did you just download that file into Colab already? If you did, I missed that step.
Yeah, so this, if you click that link, it should download to your local machine. And then here, if you just go to Google Colab, right, it'll take you to a page like this, and then there's an upload button here that will let you drag that up into your Google Drive. and I don't know if it opens automatically, but I think it does. Just out of curiosity, how many of you have used Google Colab before? Oh wow, a few. So like, not quite half, but that's good. So help the people around you if and when we run into issues. It's well, intuitive is always sort of personal, but I find Google Colab pretty intuitive. Just giving people a minute so that I don't want to leave anybody behind from the start. Oh, this page fortuitously opened, something I didn't have in the notes, but found out over the weekend is that if you're a teacher or a student, you can have free access to Colab Pro, which will give you some nice features, especially for sharing. I don't have any notes on how to do that, but I'm sure you can figure it out by Googling. You have to give them ID, some proof that you're a student, but it was fast. Like it took me 2 minutes. I don't even remember what I ran into that I couldn't do without the Pro membership, but anyway, I now have a little Pro with my icon. Has nothing to do with my skill level. It has to do with whether I am a teacher or I paid. All right, how we doing? Everybody can see the worksheet? Doesn't look like that. Looks like this. When it opens, this sidebar may be closed, so it may just look like that if your screen looks a little bit different. I won't talk about all the navigation stuff today. I'll hit on quite a few of the features, the main, most used features. But that window that automatically opens on mine is a navigation pane. And then the other one that I use the most is the bottom icon there, which is a file icon. And this gives you a file explorer. Right now there's not much there. By default, when you start a notebook, you are starting a runtime. A runtime is essentially Google giving you a little computer in the cloud, and it has a whole file system, like almost like you would see on a regular Unix computer. In the directory that I'm in right now, there's just this folder that has 2 dots. What do you think that means? Yeah, to the parent folder, right? 2 dots is go up 1 folder in the directory. Somebody did their Unix homework. And then this one is sample data. So it has a sample data set, or a folder of sample data that go along with some of the tutorials that Google has built in for learning to use Google Colab. And I should say that lots of what we went through, there's an attribution statement at the bottom that we'll get to. This is aggregated and adapted for the course for this course by me from Google's own tutorial stuff, sort of collaborating with ChatGPT and Gemini. Okay, so what is Google Colab? Anybody that's used it want to tell us, answer that question? What is it? in your own words. Obviously, you could read what's on the screen. I could read it to you. Pure fun.
Yes. It's basically a notebook where you can code in Python, and it's like a Jupyter notebook that you would download from Anaconda, except it's web based.
Yeah. So, what's a Jupyter notebook? Like just the term notebook is well, the easy answer is you're looking at one, right? So you have opened. This is a Colab notebook, which is effectively, like you're saying, a Jupyter notebook. It's just a Jupyter notebook that is housed on Google's hardware, and it has a couple of nice additional features that you wouldn't have access to on a standard, like you were saying, if you downloaded Anaconda and have Jupyter Labs or Jupyter Notebooks on your local machine, you might not have all the tools that are built into Colab. One of the awesome things here, let me blow this up a little bit. Still not going to read all the text to you. But I will say it's worth going back because, again, just sort of like the tutorial we had last week, there's a lot. These are dense documents. Okay, there's a lot of information here, not a lot of fluff. But one of the great things about Colab is that you do have access. We won't take too much advantage of it in this course, but it gives you access to GPU hardware, sort of things the kinds of hardware that you need to run large language models or train big data sets. Still debating. We may do some big data frames on a GPU when we get to the machine learning part, but we'll see. For those of you who have never seen one of these notebooks, I don't know if these are auto expanded for you guys when you open it the first time or not, or if they're closed. But in terms of navigation, right? If you click that arrow to the side of the header, you'll see the sort of absolute basics of what a Colab or a Jupyter notebook is. It's comprised of cells, so you can kind of see the header cell, that's a text cell. So then I click down on the next cell, and the text cells are in Markdown, which is kind of a language similar to HTML, sort of, and you can put HTML in these, which we'll get to later. If you double-click a text cell, so go ahead and do it. So if I double-click that, you can see how it changed to now you see some sort of code indicators there, like this. The two hashtags there say make this a level 2 header, and I don't expect you to know Markdown already. I'm just trying to show you introduce you to a notebook right now and what's in the notebook. But this window that I'm looking at right here is how I would edit what's in that text cell. So you can see how it shows up down below, right? So that's what you could see before, this part. And whoops, this top part is where I have to edit that. So for example, if I take away one of those hashtags, the size didn't change that much. Let's shrink it, make it more obvious. Right, so you can see if I drop that down to a level 4 header, how the text cell shrank. So you can see your edits in real time and how it's going to show up once you exit out of that. So to get out of the text cell editor, last thing, this isn't in the notes, but some people like to edit, I like to edit it top and bottom. Some people like to edit it side by side. So this little icon right here will switch the editor mode for text cells to go side by side or up and down. I like to do it up and down just because the visual of my text, it's going to be in this kind of layout, not the scrunched layout. So personal preference. So to get out of that, I just need to click on some other cell. So if I click down below, it jumped the page down to the cell where I clicked, but the editor went away. Okay? So that's text cells. The other kind of cell in the notebook is a code cell. So here, I have this right here is not a code cell. It's another text cell describing what a code cell is. Right below it, this is a code cell. So this is where I can, for now, we'll say just enter Python code. Jupyter is an interactive Python interpreter. So that by default, the code cells are going to interpret the code as Python coding language. So here I've named a variable a and said make a equal to 10, and then just putting a there is going to return that. I could also put in a print statement. We'll get to that later. And then to run it, hit play. Yours, I don't know if yours populated with outputs or not, but I can click on this little button right here. Sort of getting ahead of myself, but if you click that button, it gives you options to clear that output. And I run it again. Okay, so those are code cells. If you want to add a new one, you can see when I hover right between cells or right at the bottom of a cell, you get the options to add a code cell or a text cell, and it will insert it right there between the two cells where you're at. The other option is to, too big, in the nav bar up here, you can hit plus code plus text, and that will add a code cell or a text cell right below the one that you have active. You can delete cells by hitting the trash can on the little pop-up menu bar that comes up. So again, these are the kind of things that this is why I was saying I find Colab sort of intuitive, right? I want to delete a cell. The pop-up menu comes up and it's got a little trash can. What do you think that's going to do? Okay. You can move cells up and down. So let's say I want to move this code cell up above that code cell text. I can hit the up arrow and see how it just jumped that cell up above. Okay, and so then I can move it back down like that. Right? So that's cells. Sometimes, and I want to put this at the top in case you run into issues when we get to coding, you want to stop a cell that is just running continuously. Or you realize you made a typo or a mistake and it's not going to work in the end, so you want to stop it rather than just let it go. So you need to interrupt the code execution. In this example, it has a timer and it's just going to run. Right? So it says it's sleeping. I can just hit the stop button and that will interrupt the code. You can also do Control MI. Why they did Control M, I don't know. Also for you Mac users, the command key and the control key are often, like if you're in a Unix environment, you have to use control, not command. And as a Mac user, I'm used to using command for everything. In the Colab notebook, it seems like it doesn't matter whether you use command or control. They both work the same way in the Colab notebook. I don't know if that's universally true. That's just my experience. Okay, questions about what's a notebook? What's Google Colab? Those are the absolute basics of what you're looking at.
So I'm not really all that familiar with Jupyter notebooks, but like I think from what I've seen previously,
Yes. It is smart about, at least, I'm hesitant to say universally, but yeah, it's smart with opening big data frames. Like a FASTA file, maybe don't think of that as a data frame, but it's a big chunk of data, and it won't store it all in memory. Well, actually, there's a video at the end that will give you a cool example of how smart it is with things like big data frames. Okay. Well, how do we use it? So let's look at some tools. So as you're learning to code, one of the nice things about Jupyter Notebooks is that it interprets code cell. Code cells are code aware, so it sort of understands what you're typing. It's more than just the spell checker in Word. It understands functions and can complete things. So if you expand the rest of the cells under the tools for coding, here, this first cell is going to import a package called NumPy. We'll get to importing and what that command really means later. Now, in the next cell, we're calling this package. So the package is really a whole bunch of functions that have been put together. In this case, they're all things like generating a random number. I would use this NumPy package to do. And that first statement said, we're going to call this package NumPy just NP whenever we want to call that package or use a function from that package. So here, if I hit the dot, whoops, come on. Got a syntax error there. Right? So, because I put the dot before I hit the run, there's nothing for it to actually run in this cell. Right? Let me clear that, go back and show you what happens here. And sometimes it takes a second because it does have to go access the NumPy library. And so these are all the functions that are built into the NumPy package. Right? So it's even better when you start typing, right? If I want to do square root, right, it gives me the syntax. Like I can't remember, is getting the square root SQT or SRT, right? This is where that is super useful. Whoops. Come on. So that was an example. What just happened. Because you can't see my. If I hit Command Space on the Mac, it opens the Spotlight. Like this is the File Explorer, file search for Mac. But so it has to be Control Space to bring that back up on Mac. So similar, let's say I've already got my function. Oops, got to run it. Right, so if I hit the parentheses, it brings up the documentation for that function. So how does that function actually work? What parameters do I need to give this function? Because unless it's a function you use all the time, There's so many, it's easy to forget exactly the syntax you need, okay? Also where AI will be very helpful. So Control Shift space to bring up documentation. There are all kinds of little things that you will learn along the way. Things will pop up. It's like, oh, that's a nice little tool. Okay. And the only way to learn all of them, there's no way for me to cover them all, is to play with the notebooks. One of the great things about Colab is that most of the really popular, commonly used Python packages are already pre-installed, like NumPy. I didn't have to install that, I just called it. So Pandas, which is the module or package that helps us deal with like Excel spreadsheets, so data frames. SciPy, Matplot, Seaborn, scikit-learn, these are all super popular. We're going to use all of them. And even if it's not in there, pip is a package manager. I'll talk more about it at the beginning of the Beginning Bioinformatics 2 document. But the fact that you can just type that and it works and it installs BioPython, it's something that you can't really appreciate when that doesn't, if you've ever been in a situation where that doesn't work and how hard it is to get that environment working on a local machine sometimes. Yeah, this will save you lots of headaches. Not just for this course, but generally, the fact that installing packages in Colab, I have yet to run into one problem that took me, like in all of the ones that I've installed, as much time as it takes to get BioPython working on everybody's computer in this course for one semester. It's super nice. Okay, so just with that, like knowing that these packages are installed, just wanted to give you an example of why this is amazing. So you already in this notebook have a very cool superpower. So there's an example here with a question. All else being equal, how does the number of genotyped individuals affect our ability to detect causal variants in genome-wide association studies? So, anybody, what's the intuition? Answer that question for me without doing anything in the notebook yet.
Maybe if you have more genotyped individuals, you might have a harder time detecting variants because there's just more to look at.
Interesting intuition, yeah. So, but no, like that's why I expect to kind of not know, and that's why it's an interesting question. So we can answer that question again. Actually, anybody want to take the other side of the argument? So the answer was that more individuals might make it harder because there's more variants to look at.
If you like screen a lot of people and they have a similar like sequence, then when you see ones that are different, they'll probably pop out too.
So more would be better because you're screening more and you have more opportunities to make the association between the variants and the trait that you're looking at. All right, so if you scroll down, there's a little side note here about hiding stuff because this is a long code chunk. All you have to do is hit play right there. But just a note to say, like, we already saw how you can expand these, but you can make all that big code chunk go away just by clicking the fact that this is a header. And if going to the navigation pane, just make a mental note of using the markdown to help you organize your notebooks. Because expanding and collapsing these things so that you hide really big code chunks can make your notebooks way easier to navigate. And this side panel just lets me jump around to specific topics. So hopefully, if you have to come back to, hey, how did that work in Colab? You can open this notebook and you've got like the cheat sheet version in the nav pane, so you can jump to exactly what you need to know. Okay, so run that cell, and it can run while it's hidden even. And mine ran super fast. But this, another great thing, it doesn't matter how fast your computer is, because this is running on Google's computer, right? You're in a browser interfacing with Google's machine, who knows where. Okay, so run that a couple times and look at, if you scroll down to the bottom, the output of this code chunk is called a Manhattan plot. What this is showing you, for each of the dots along the bottom is a SNP location. So a SNP, single nucleotide polymorphism. So this is a DNA variant. What you're seeing on the X chromosome, the X axis, is the 22 chromosomes. So they alternate colors just so you can see the breaks between the chromosomes. And then on the y-axis, you have the negative log p value. And so negative log p is something you often see graphed just because it means the higher up the dot is, the more significant it is. So it sort of reverses. Normally p values get small, they're more significant. So taking the negative log just flips the scale, make it more intuitive visually. So these stars that are super high are sort of the planted variants, because the code puts causal variants in the data. And so if you run this a few times, you'll see it's generating the data randomly. So I'll talk about what the data is in a second, but see how now my variants changed? But mostly the non-causal variants are all clustered down there on the bottom. The dashed line is the Bonferroni corrected significance level. This is just a multiple testing. Since we've tested 10,000 SNPs in this case for an association with the trait, we can't just use a normal 0.05. Good question. I'm gonna let you find that yourself. So, like, that's the end of the day. Like, go back to this code and have Gemini explain it to you. So it's sample. So answer your question, since you didn't know that was the end of the day. So right here, this is generating SNPs based on a multinomial distribution. And then it generates the phenotype on a random distribution as well. I think the distribution for phenotypes, here actually. This is where it's simulating the genotypes for each individual, and then getting the quantitative phenotype is down here. So there is some commentary, but obviously there's a ton of code there that if you don't know Python, it's just gibberish to you. Okay, I get that. So to answer our question though, right? How does the number of individuals in our study affect our ability to detect causal variance? So right here, I'll blow this up. It's probably too small for you to see. Come on. There we go. Come on. These are the settings for the simulated data. So I have 800 individuals being simulated. In each of those individuals, there are 10,000 variants that we measured. Okay, we'll talk about how this all happens later in the semester. 22 chromosomes, and I'm saying simulate 6 causal variants. So what happens if we cut that in half and make only 400 individuals and rerun the cell? Okay, so not too different. Let's cut it in half again. Oh, now we're starting to see something. Okay. Also, notice the scale of the y-axis as this happens, because it's smart in terms of its axis generation. It's doing it relative to the data. Cut it in half again. Now we're getting a really small study. Well, actually, 100 individuals for some studies, not bad. Oh, and now look what happened. The dotted line is way up there at the top. Our simulated causal variants are down. Some of them are down here in the noise. So, what did we learn about the question? What is the answer to the question? This is a real bioinformatics question that I don't know who has better intuition, a data scientist or a biologist, about what the answer ought to be here. Still don't know the answer. Yeah?
You need more individuals to better detect causal variants in GWAS?
You need more individuals. So how did you come to that conclusion based on what we just did, that exercise?
Well, the significant SNPs, they only really show up when you have more, otherwise they're below the line.
Yep. So you guys hear that over there? Right. The more individuals you have, the more, in stats language, we would say, the more power you have to detect association between causal SNPs and their phenotypes. Okay? And the way that shows up in the data in these simulations is that all of these non-causal SNPs, right, their significance level was all scrunched down at the bottom, and the true causative loci popped out way high, because, right?
Yeah, 10,000 individuals makes it way clearer.
Yeah, also. Yeah. Good luck getting 10,000 individuals in a GWAS study. I mean, we're getting there. We're going to talk way more about that one. We'll do a whole unit on GWAS to talk about what just happened in all that code. And why the question is caveated by all else being equal, because we have to think of all kinds of biology in there too. All right, so Google Colab notebooks, so far our outputs have been static text, like A equals 10, and then print A, and then you just get static text, 10, right? Even this really cool code generates a static figure, but you can do super cool figures in Jupyter notebooks. So run this code. This is going to simulate little 10,000 base pair chromosome, genome, DNA sequence, whatever you want to call it, and then graph the GC content. But it's not just a static graph. So you see when I mouse over it, you can see the position and the GC content, the local GC content. I can also drag a box around it to zoom in on a specific chunk. You can see I have a new menu up here. It lets me zoom in and zoom out. You can, let's zoom back in there. Zoom in on a chunk. You can pan from side to side. Whoa. Sorry. You got to switch the tool to pan, and then you can drag it. Okay, so that's, I don't know, that's why I feel like I've got superpowers in Colab. Because AI will give you the text to do that in about 5 seconds. Obviously, to make it meaningful, you've got to have a pretty sophisticated prompt to tell it what kind of data and what you want it to be able to do. But and I guess just what are we looking at? The position across the genome, and then the percent. I guess it's shown as a proportion of G's and C's. I don't remember the window size. It's 100 base pairs. Yeah, so it's calculating the percent of G's and G or C nucleotides in 100 base pair windows. And like, this is how you learn stuff in this class. Play with it. What if I make the window size 1,000? Okay, it's gonna probably smooth that out. Whoops. So interesting. Anyway, that changes the window size. It's still plotting it for every window, and there's interesting ways that it deals with the ends of the chromosome. We may look at that more when we do Rosalind number 9, where you have to calculate GC content. I think that's number 9. All right, last few things. You've already seen how this is integrated with Drive. Anybody use the share link, or did you download it and upload it? You did the share link? Okay, worked easy? Had to make a copy? Okay, yep. So, just like it says there, you can use the link, make a copy, save it into your Drive. One of the cool things, and this will come up again, but the revision history. It auto-saves your changes to your Google Drive, and then if you click on that little cloud thing, it shows your revision history, and you can even tell it which things to compare. So, well, you get it. We're losing time, and I want to get to the Python stuff. Okay, so there's a revision history, and we're going to talk about version tracking more on Thursday when we look at GitHub. Just pointing out that it's there and that your work in the notebook is auto-saved. You can do commenting if you've ever used Google Docs or even now Word online, where you can see other people's comments if you've shared the document with them. Just a great way to collaborate. Also, I mentioned this earlier about running HTML. Notebooks are not limited to running Python code. So some examples. Here I've given an example running Bash. So just like the environment we were in, well, not just like, but how we ran Bash Unix commands on bridges last week, you can run those kinds of commands in Colab notebooks. You can also run HTML, just giving a couple examples there, showing you some of the cool HTML, you can do it, and it basically turns into a HTML interpreter if you put that in a code cell. I have a little bit more here about shortcuts to the Unix system, just because there are some shorthand ways. You don't have to run a magic that's the %. So the way you initiate a magic is %% bash, and then that's telling it interpret everything below this in the cell using a bash interpreter. So you can do many bash commands by starting the line with an exclamation point. That exclamation point will tell the Colab notebook, interpret the rest of this line with the bash interpreter. What that lets you do is things like this code cell, where I write some Python code to define a variable. So I'm defining a variable called path and saying I want path to equal this path to my sample data. Then I can use this bash command, ls-l, and pass that Python variable into the system prompt. Okay, so this will print the list of what's in my sample data, and that's what you're seeing down below. I don't want to spend too much time on these. These are things that I don't expect you to necessarily just remember, right? I realize it's a little fire hose, like just spraying you with information. But hopefully some of it sticks to know, like if I need to know how to do something in Colab Notebook, I've got a notebook now to go back and look, okay? There are also some things like ls are so common that you don't even need the exclamation point. It just knows. That's a bash command. Okay. And just because I could, like, you can use all the options for some of the, not some, you can use all the options for the commands ls. If I want to color that, we showed in Bridges shell environment how color coding can tell you what's a directory versus a file that's executable or just a plain text file. Okay. If you want to know what else Colab is smart about knowing, giving you that. For those of you who are experienced coders, none of this is new. Do you know how to add aliases to your notebooks? Okay, so the answer is change your .bash rc, but where does that live in Google Colab? That's a little too far down the rabbit hole for an intro to Colab notebooks. Okay. Last sort of important thing is how do you get data in and out? So when we get into some of the Rosalind problems, probably starting around 4 or 5 writing files, you're going to need to be able to access data from outside the notebook. And so here has a file upload function. This generates data and then actually, not this one. It's the download one. But this code actually gives you an option to bring up the file browser on your local machine. So it makes it very easy. So that's one way, and that will upload that into your current runtime. What's the runtime? It's the cloud computer that you're working on, right? This is the Google machine. When I was talking, so I mentioned it when I talked about the file browser earlier, okay? the thing to note is that if you have stuff that's in your runtime, when you close this down, that computer goes away, okay? And so be careful. I've got it in the notes in a couple places that you have this saved to your Google Drive. So that's the next bit. Mount your Google Drive. So there's code here for you to do it. You can also do it by clicking this little icon right here. Mount the drive. That's the easiest way. And so if I click on that, it's asking me to, that's interesting. It's asking me to run this code to mount my drive. I don't know why that is. Either way. It's taking its time doing it too. The important thing to take away is that you need to save your data or the files that you want to keep to your Google Drive, because they will go away if you only leave them in your runtime. Okay. The notebooks are auto-saved to your Google Drive, so it's not the stuff in the notebook that I'm telling you to worry about. It's any data files or outputs that you write. Make sure that you save them into your Google Drive. I don't know why.
I think it's also important to note that you have to re-upload most of the time when running code related to that file. So then you have to run all your code before you can access the data. Because if you don't upload it again, it'll come up as an error not found because it's not there anymore.
Yeah. So we'll get into the sequential part of the cells, right? Is what you're talking about. If the data's not there and you try to run a cell that needs it, then it's going to give you an error because it's only in your runtime, or I don't know if you're talking about a path problem or an updated data problem. They're both potential issues.
Yeah, both, I guess. It's happened a lot to me.
I'll try to remind you of those kind of things as we go along, but when you're working on homework and stuff like that, keep it in mind. It's interesting. This is the first time I've had a problem with it mounting my drive. Anybody else have trouble having their drive mount right now?
Yeah, I'm having trouble. It says permit this notebook to access the Google Drive files.
Yes, so you do have to authorize it.
So I got the email. It said it was authorized, but then when I tried to run it again on the laptop, it says it's not authorized. You have to Google Drive on your desktop to access some of your Google account.
There are, I think there were like 2 or 3 layers of authorized, but they were all pop-ups, and I just clicked whatever the yes equivalent was. But I've never just had it spin like that, so I don't really know what's happening there.
Is it already mounted by any chance?
It shouldn't. I don't have any other ones open.
Camry, on the left of the pop-up, does it give you an option to say sign in to Drive and then just click that?
Mm-hmm.
It did, okay.
Yeah. Let me see if it's gonna let me run it again.
Okay.
It
I
let me
I reloaded my page, and so you can see these are the authorizations I was talking about. So I had to hit continue, continue. Now it's doing its thing.
How much do you want us to give it access to?
I'm not sure I understand the question.
It gave me like a bunch of options.
Yes. So you have to hit select all, because
All
I
of
only
them?
hit one file, and then that's why it wouldn't let me work the
Oh,
next
okay.
time.
I gave it content to all my whole drive. If you're not logged in as you won't be able to go. Like, Colab knows like who you are relative to your drive. So giving it permission is still it's just the two applications being able to talk to each other. It's not sharing it outside your own account. Now, whether you trust Google to not be doing that, I don't know, but that's... and so when it works, which finally it did, you can see that, whoa, now I have this drive mounted, and inside that you got my drive, and for me, there's a ton in my drive, okay? So you've got to save stuff into that drive. We'll talk more about doing that down the road. If you run these cells, this generated a file, and then put it in your drive. So I don't know if you can see. And again, I don't expect you to understand the Python code necessarily, but hopefully, one of the cool things about Python is that I find it's pretty readable. So it opened this file called foo.txt in content, drive, my drive. And so if you remember from back on the file explorer, /content is like your default directory. So you don't see the /content. What you see is /drive, /my drive. And then if you go into your Google Drive now, you'll see a text file called foo. And then what it did is it wrote hello Google Drive in that foo text. That's what this is doing. Okay. And then that's just a command to say, hey, command shell, write whatever's in that file to the output. And so that's why it actually printed hello Google Drive. It went and read foo text from your Google Drive and wrote it to the output. And then the last one there unmounts it, and so it closes everything and saves it, shuts down your drive. Okay. I sort of skipped over downloading, but it's also kind of if you have that code, it's pretty simple. That's downloading from your Colab to your local machine. And then so many great tools. These are just videos that you can watch. So if you play these, again, these this is the one I was talking about, interactive tables. So like beyond pandas, for those of you who've ever used data frames in Python, Colab has some very cool interactive data table structures that you can play with. And then last but not least, Gemini. So in all the cells, when you click them, you get this pop-up bar. That little star is the star to access Gemini. If you're in a code cell like this, you can click that and ask it to explain the code. That's the one that I use it for all the time. And it will pop up and tell you what the code does. Very useful when you're trying to learn code. So you could go back through this whole notebook, and so it thought for a second and then tells you line by line, command by command, what that code does. And you could go back, like I was saying, for the example about the GWAS, how you could go back and say, like, where's the random data being generated? Okay, Gemini will tell you. Okay, And then the other way to access Gemini more generally, like for not just a code example, come on, is there's another star down here at the bottom, and that opens up the chat bot. Okay? And so this is where you can ask it to code for you, not just explain the code. You give it a prompt and it will generate code. And not just generate code, it will like populate that code into your notebook so that you can just go ahead and run it. And stuff like this is why this is a whole new course. This didn't exist a couple years ago. So there's the warning about making sure that you save everything to Google Drive, or you run the risk of losing it. And like I said, this whole document, collaboration between me, Colab, Gemini, and ChatGPT. Any questions about Intro to Colab? Yeah.
I don't have that video. I'm going to try to press the link to use Gemini. That one.
This one? So if you run the cell
Yeah, I ran the cell.
and it doesn't, like this isn't working?
Name error.
Hi there, I'm Julianne.
Oh,
I'm
that's
a software
interesting.
engineer on the Colab
Try
team.
reloading your
I
page.
primarily work on
I'm wondering
Colab's
if there.
AI features. Today we're talking about Colab and 3 AI-powered tools
Oh, yeah.
you're using right now to supercharge your
One of
development,
it, like,
whether
is,
you're
like,
a seasoned
imports the
developer
YouTube
or just
video,
starting out.
and then the next one is the same thing.
Good call. So this code cell has 2 extra lines in it where it's, so if you haven't run this cell where I load the IPython module, the second cell, this one won't work. So if you run this one and then this one, that was in some ways me being lazy, I think, of just not, good call. All right, any other questions? Yeah.
So mine, when I do that, even when I run the first one, just says watch video on YouTube, video player configuration error, and it's just like a gray box.
Interesting. That I don't know how that can happen. Let me look at it after, because those kinds of problems are interesting to me too, in terms of how there are an infinite number of ways code can go wrong. If you don't already know that, you will learn it pretty quickly. Okay, let's, we've got 15 minutes. See how far we get in, not that. The beginning bioinformatics Word document. So this one, right? So part 2. Intro to Colab took a little longer than I thought, but so this gives you what I'm hoping to get to for the rest of the week, right? So we kind of have our workflow set up for Colab. You at least hopefully have an idea how to access it and use it. We'll do GitHub on Thursday. Then we're gonna now get to Python. Okay, and then the rest are sort of specific to what we're going to get to in Rosalind. Maybe we'll get to the first Rosalind problem before class is over. Just like I did the Why Learn Unix in the age of large language models, I think it's fair to ask, do I need to learn to code? Seemed like a silly question not that long ago, but I would encourage you to ask ChatGPT. It's kind of fun. Which programming language do you learn? This is more of the why code Python. What you will probably find is it's the most popular language in data science in particular. There's an argument to be made that R is still more popular in bioinformatics specifically. But machine learning and AI, prototyping and development especially, the front end is all Python. It's all Python. And so I would say the most rapidly developing tools people are all coding in Python, not in R. And so eventually, I think Python is going to overtake R, even for bioinformatics. But this was the quote that GPT gave me a few weeks ago. I like this, don't overthink it. The irony here of AI telling me not to overthink something. Like basically they're saying just master one of the languages and it'll make the rest easier. Okay. But is it telling me to cognitively offload at the same time it's telling me to just learn a coding language? I don't know. Just struck me as funny. Before we get started, one of the things that ChatGPT probably won't tell you if you ask it those questions is that one of the things that makes Python awesome is the modularity. Like I said, people are developing packages that most of them are open source, and you can just, you see a paper published with a new method, you can just call that method. You can use pip install and get that method in your notebook and use it. So that modularity is awesome. It's not true for all programming languages, but the however is that you run into these things where when they were developing the package, they were in a certain coding environment with a certain set of other packages running. All of those packages are constantly being updated and revised. And sometimes the difference in revision number breaks the interaction. And when that happens, you get into something called dependency hell. Because you're trying to get all the versions correct for it to run in whatever environment you're in. This has gotten a lot better over the last several years with package managers. They've started to be smarter, not so surprising. And we're going to avoid a ton of it by using Colab, which keeps everybody, in here at least, environment the same, keeps most of the versions the same. That pip install for BioPython, you can tell it specific version number in the pip install command. And so I'm not going to say too much more about that. It's just to raise awareness that as great as Python is, this is one of the downsides. That modularity comes with some overhead. And hopefully you never run into it, but chances are if you stay in bioinformatics, you will. All right, let's get started doing some Python. So go to Colab, just start a new notebook, right? Google Colab, or if you've got it linked, just go there. It'll pull up this page again, start a new notebook. And it doesn't really matter what you name it. I've given you this just for uniformity, so everybody kind of has the same thing. And so I copied that and I'm pasting it in. Nope, paste doesn't work. Okay. gonna add a B there before it autosaves so that I don't have a version conflict. But that's just me. You guys don't have a file with that name already, so you don't have to worry about it. Okay, and like we said, when that little cloud with the check mark pops up, that means it's autosaved. And it's already tracking our versions. So, step 2, your first command in Python. I think it's mandatory that when you're learning a language, the first command is always hello world. You see if you can make it print hello world. If I had a nickel for every time I've printed hello world. Okay, so how do I execute it? I could have hit the play button. I'm going to hit shift return. Back in the other document, when I talked about running code cells, there's a whole list of ways you can do it. Okay, but everybody able to print hello world?
Do you know why?
Are you laughing because it's so easy? Too easy?
Do you know why specifically hello world is just that? That's just a universal.
I think, well, so the meaningful answer is not about the hello world. It's about the fact that the print statement works, because that says that everything in the environment is functioning correctly to send you output, okay, to interpret the code and send you output. The hello world, I think, is just it's like this sci-fi, the computer is telling you hello. So that is the computer saying hello world, right? All right, so if printing something is like the first thing you learn when you're doing a language, the second probably thing that comes up immediately is how do I assign, like tell it that something has a value. So the assignment operator. In Python, the assignment operator is an equal sign, okay? And so, and this is, you know, Python is a very readable language. X equals 5 does exactly what you think it should do. It makes the X equal 5. So now there's a couple ways I could have that send it back to me. I could just type X and run it, and it prints 5. Or I could use my print command that I just learned and say print X, whoops, shift enter. Okay, same thing, okay? And that's just a shorthand that's built into Colab notebooks where I can just tell it the variable name without having to go through the print statement and have it do the same thing. Just handy. In the form, I say ask Gemini to give you 3 examples. So as you're working through this on your own later, going back, what I mean is hit this little bubble. Whoops, bring up the chat. I don't know why my paste is not working here. Give me 3 examples of how to use the assignment operator. Okay, and it'll work for a second. I don't remember exactly. Oh, I said practice understanding the assignment operator, but so this is what I mean by it populated my notebook with 3 examples for what it looks like to do assignment. Okay? I've given you the best practice for naming variables. This is just standard operating procedure in Python. I actually don't know how AI is affecting this, whether it sticks to this. This was, it just makes code more readable when you give your code to another Python developer, for example. They'll be easily able to go through and say, okay, what's a package or a function versus what's a variable name. Data types. I'm going to let you look through this stuff just because we're almost out of time. And this is, again, asking Gemini to help you learn. Okay? So you can ask Gemini to give you examples of each data type just so you see what they look like in the notebook. Here, pretty straightforward what the arithmetic operators are, and then you have another whole set of comparison operators. So maybe the one you'll use the most, at least at first, is the double equal sign is a comparison operator. Is this thing equal to this thing? Not make this thing equal to that thing. And so that's what this text is. Don't confuse equals assignment with the question, is it equal to? Okay? So the equal will make it will force it to be the same. The double equal will ask, is it the same? And so now the last thing here is Rosalind 1. So if we go over to Rosalind, variables and some arithmetic. Rosalind problem 1, whoops, come on. Says if we're given two positive integers a and b, each one's less than 1,000, we want to return the integer corresponding to the square of the hypotenuse of a right triangle. So just intuitively, forget code for a second, what do we need to do? You can even use those numbers if it helps. What's the equation? Yep, Pythagorean theorem, which is? Yeah, a squared plus b squared equals c squared, right? And c squared is the hypotenuse. I'll tell you the thing that trips people up on this question all the time is they try to get square root. They're trying to answer c. It's asking for the square of the hypotenuse, so you only need c squared, right? So people try to do the extra step and make it more complicated than it really is. This is actually easier, right? So we just need something like c equals a squared plus b squared, right? That's the answer. So 3 squared plus 5 squared is 34. That's the right answer. 9 plus 25. Okay? So then the question is, how do you get that into here? So let's go back to a code cell. And I'm going to say C equals, right? Because A, and how do we do squared? What's the arithmetic operator for squaring something or raising something to an exponent? In Python, it is asterisk, asterisk. So like asterisk is the multiplication symbol. If you put 2 of them, it's an exponent, right? And then plus.
I'm so sorry. Is there any way you could zoom out a teeny bit?
Yep.
Better? Thank you so much.
And so notice the is a little interesting note, right? Get these little squiggles under A and B. What do you think that means?
That they're undefined.
Yeah, it's finding an error, and the error in this case is it's gonna. If I tried to run that, it's gonna tell me A and B are not defined. Okay. So, what do I need to do to fix that? Well, define A and B. Yeah, and I need to put it before that. So A equals. Let's use our test data. Right. And I'll also note, Python is very forgiving about white space. In this case, there's no spaces in there, but this requires you remembering your order of operations from whatever, junior high math, okay? So just knowing that the exponents are getting to get taken care of before the addition, right? So it obeys the rules of order operation. I could put parentheses in there if I didn't want to remember. I could put parentheses around a squared and b squared. Okay. So, but in general, Python is very forgiving about white space. I could put like this. Whoops, not with the period. That doesn't matter. It's going to read that exactly the same. The white space doesn't matter. And so if you wanted to make it prettier, right, you could do something like that, and Python doesn't care. So then I think I've got it. Hit run, maybe. Oh yeah, it did run. It didn't give me an error. Good. I just didn't tell it to output anything. Okay. All right, so you've solved, so how would I now solve Rosalind number 1? I think I'm ready, my code works. I'm gonna download the data set. Okay, it downloaded to my downloads folder. I'm gonna open that file. I don't know, that's super tiny. These are my numbers, 924. Back to my notebook. 924 and 856. Run it again. Get this giant number. Whoa.
Should we have those exact numbers?
Nope.
Okay.
This is the beauty of Rosalind. It'll generate random numbers for you. And then I'm going back to Rosalind. I'm gonna paste my answer in this cell. Now I don't know, that's so weird. What is that gray box doing there? Okay. Oops, crud. I don't want to do that. Anyway, okay, there we go. Choosing your code is mandatory, so you'll have to have a version of your code that you can upload. Okay. I'm just gonna give it that notebook, not the right one, but just to show. And if you had the right number in there, it tells you congratulations, you solved the problem. Okay? So that's how you solve a Rosalind problem.